Okay, thanks for coming. I am Igor Stoppa. I work for Intel Open Source Technology Center. What I would like to discuss with you today is a couple of concepts that we have been addressing while creating meta distro for IoT devices named Ostro. Keep in mind the word meta. It will come back later on. These concepts I will be discussing today are not specific to Ostro. These solutions implemented are not specific to Ostro either, but they kind of fit nicely together if seen in a broader perspective of creating Meta OS for IoT. So, I don't know about you, but I've been wondering for a while what is exactly a IoT device. And it's basically almost anything that is capable of talking to something else. That leaves, it's a quite vague definition, and this also explains why they expect such high number of IoT devices. It means that basically everything apart from your PC or phone can be considered an IoT device. I like to think about those Amazon push buttons that you use to order something. I don't know why people want them, but they are a good example of IoT device. Is there anything radically new when we create IoT device? Not so much. It's more about the scenario into which we and the device come to operate, which is different. In the end, you have a device, you deploy it, you do some sort of maintenance of the software installed, you do some sort of maintenance of its configuration. That's it. I guess this could be applied even to a blade server running a data center. What is different is the fact that the sheer number of these devices is much higher. So the blade server running on a data center, we can probably afford to put some skilled administrator to look after it. These IoT devices, the expectation is that they will address more and more critical systems aspect of our lives, and they are supposed to do all of this unattended, which means that you do not have anybody who can come and try to put the pieces together if something fails. Furthermore, as I was listening to a talk yesterday about how to migrate from a real-time OS to Linux. That's this interesting fact that now Linux is becoming more and more the standard for IoT devices. So this migration is happening with all the advantages, but also disadvantages. Surface of attack of a Linux device is much bigger than a typical RTOS one. Someone might object that there's been a lot of SCADA which have been crippled by security bugs. That's true, but in general, you have many more cases of like SSH vulnerabilities which need to be addressed. And if your house is depending on those, you might have an issue. So not only it's about updating the device, but it's about updating it frequently and fast, because you want to avoid that someone takes care of, takes advantage of a zero-day vulnerability. So we've been looking around, and we found one option. It's called software update. Well, engineers are not famous for their imagination. It's a solution borrowed by another operating system which is developed by OTC. This operating system is called Clear Linux. It's a Linux distribution. It's a binary distribution. There's a couple of links if you're interested. It's basically a distribution which is meant currently mostly for the cloud, and it's something that OTC Intel uses really to showcase what Linux can do on Intel hardware. So you can expect to find there all the tweaks that one might want to have on x86 hardware. The second link, it's a reference to Foronic, where they have compared Clear Linux with Debian, Red Hat, and a couple of more distros in terms of how do they perform by leaving all the settings to their defaults. And Clear Linux came out quite well. Which doesn't mean that you cannot achieve the same goals with the other distros, it's just that Clear Linux is tweaked for that. So let's come to packages. Packages are the typical way of deploying software in the Linux world. You can have different flavors of packages. You can have some distros which build their packages from source. You can have distros which do binary deltas of packages, but they always deal with packages, usually. Packages do not exactly match one-on-one to high-level functionality. Let me give an example, which I will carry on. If you want to install a graphical editor, let's say GIMP, that's not one single package. You might want a functionality, but you get a set of packages. And if you have been playing with some external source, it's likely that sooner or later you end up with some conflict. And then who's left to solve it? You, unless you can afford to have a system administrator. This doesn't go well on a IoT device. So we come to bundles. What is a bundle? A bundle conceptually is not that different from a package. The main difference is that you have a closer match in terms of number between bundles and high-level functionality. Furthermore, bundles do not completely exclude packages. Think about a scenario where you have a rootfs on your build system. You deploy files there through packages. And then you use this rootfs that you have just created to assemble bundles. So you have a manifest file which lists which files belong to which bundle. And then these files are assembled. It means that there's no need anymore to resolve conflicts on the target device at the moment the bundle is deployed. The only operation that needs to be done when deploying a bundle is to ensure that whatever it depends on has not been modified. One more aspect of bundles, I will come back on that later. One more aspect of bundles is that they can also overlap. So sticking to the graphical editor example, let's say that you want to have GIMP, but you want to have also some application which is just showing images. So most likely they will overlap in terms of some libraries. You will have, I don't know, PNG, GIF libraries which will be used by both. And in the same way, the bundle which contains the graphic editor and the bundle which contains the image viewer will contain the same files, but they will be just references. Okay, I've tried to make it a little bit less boring by adding some color. You can think about it in these terms. The blue kind of circle is the core OS. So it's the part which you are never expected to remove from your system. It's the life support for everything else. And then what I drew in yellow, pink, and greenish are three bundles. You can see that each of them is partially overlapping with the core. They are those areas I labeled A1, 3, 4, 5. And then two of these bundles are even overlapping among themselves. That would be C1 and C2, and their overlapping is B. So you think about GIMP as the pink one, your favorite image viewer as the yellow one, and the overlapping part, B, as the graphic libraries that they both share. So let's assume that you start with the CoreOS bundle, and then you install C1, and then you install C2, and then you want to remove them. When you remove C1, let's say GIMP, the overlapping area B will be preserved because it's still required by the graphic viewer. After the graphic viewer is removed, also B will be removed. What happens when one installs a bundle is that the software manager, which deals with installation and removal and updates of bundles, refers to a set of manifests. And each manifest has a reference to all the files that belong to a bundle with a hash. So the software manager will check on the local file system, do I have this specific file? And if yes, does its hash match what I expect it to be? If the file is missing, it will be downloaded. You also have an option from the software manager to just tell it, scan all the files installed on the file system and restore them to their expected initial state. So it will check them all, and if for some reason a file has a hash which doesn't match the manifest, it will re-download and reinstall such file. This guarantees that even if the system has been tampered in some way, you can go back to initial state. Of course, one can always argue that what happens if the software manager has been tampered through. So you can see this more of a recovery mechanism rather than a security feature. But it's still nice to have. So, okay, this is basically a more itemized version of what I just said. Is there any questions so far? I know that the topic might be a bit strange if you have never heard it before. Yes?
This may be best asked at the end, I'm not sure, but I understand your concerns about packages, package versions, and having mismatches.
Yes.
I'm not quite seeing how bundles fixes that.
Well, the advantage of bundles is that everything is done up front during the build phase. So bundles do not automatically solve these issues, but what they do is they allow these issues to surface in the build server. So if you have an issue, you can solve it in your CI system once, and then you can be sure that all the files that belong to the specific version that you are, let's say that you are building the new version, new release of your software. Once you have solved the issues that might have arisen by conflicts in your CI system, and you have obtained a set of bundles out of it, they will all refer exactly to those files that you have vetted, and you have said that, okay, these are fine. So you do not have the risk of having a conflict to surface on the device in the wild. If a conflict exists, you will see it in your CI system.
Okay. Does it mean you can't install a bundle later after the...
You can, but the bundle has been put together starting from files which were already validated to be working nicely together. So imagine that you have your own system and you want to replicate it. A bundle, you can think about it almost as a sort of a partition backup. So you have created a system which works well for you here, and you want to scale it up. But the advantage of bundles is that you do not necessarily have to make an identical copy. You can deploy a subset of it, and then on demand install additional parts. But since it always starts from the notion that each bundle is a subset of what you have installed initially, there will be no conflict, assuming that you have solved it up front.
I don't quite get the difference, but I don't want to delay it too.
We can talk about it later. Any other question? One thing that the software update is also capable of doing is it can rely on binary deltas. This is not a completely new concept. For example, Zipper, OpenSUSE at least does that. It can download deltas of binary packages. You just have to think about this applied not to a package, but to individual files. But it's the same concept. So if a package is changing only slightly, what the software update server, when it creates the update for the new version, will generate is not the entire new file, but just the delta. Of course, what happens is that during the life cycle of a distribution, you end up with many versions. And typically, you do not have the possibility of doing progressive update from everything to everything else, because it also takes a lot of space on the server. So imagine that you have decided that you want to support incremental updates only between only from the previous two versions of the current one that you are building now. Let's consider version N, the one that we are just building, and we have decided that we will support two versions before, so it's N-2 and N-1. What does it mean? It means that the update server will have information for bringing each of these two versions up to speed with one single step to version N, and it will have it in an optimized way. What happens if you are somewhere here? You do not have that sort of incremental information. What happens is that then the system will refer to version 0. Version 0 is what you can think of a completely empty rootfs. So all the files of the new distro are present in the update data for version N, starting from version 0. Is this equivalent of downloading a completely new image? No, because let's assume that you were here and you had a file which is identical to the file that is here. The software updater still has the information through the manifests of what files are present, what is their hash. So it will look at, okay, I need to have a certain file. The hash of the file that I have on the file system is this. If it matches the hash that I'm expected to have later on, then I will not download it again. I will download only those files which have a different hash. The optimization that happens if you happen to be in one of those distributions which have a direct arc connecting them to the latest version is that you have a binary delta for those files. You do not have to download them completely. But it can be thought as a sort of second level optimization. Is there any question about this? Does it make sense? The purpose is really to download as little as possible so that only those parts which have changed get downloaded. And the decision whether to provide a binary delta or a completely new file is something which is calculated during build time, because at build time you have the source file, the starting file, the end file. You can check how much they are different. And for example, if the target file is completely different from the previous one, it might end up that the binary delta is actually larger than the file itself. So at that point, it's preferable to put just the file, and then the updater will download that. Now we come to how this is implemented inside Ostro. If you remember at the beginning, I said, remember the word meta. So when we are talking about Ostro, we are talking about a tool which allows OEMs, ODMs to create their own distro. Imagine ODM which is creating, I don't know, home gateway, but it could be some heating control system, whatever. So most likely this entity will want to have control about the software that goes on that device, which means that this ODM will create their own signed software update stream. So the device will not receive updates created directly by us, the Ostro team. It will receive something which is post-processed by the ODM. The ODM might decide to add, remove some components. For sure, the ODM will sign them using own key. If you go to the Ostro project website, you can download images which are signed by Intel, just for the sake of providing proof of concept of how this can be done. In this case, Intel put on the hat of ODM, and you can experience how it would be. But if you want to, if you are the ODM, if you have customers, then you become the signing entity. What Intel provides is the estate cache, so you do not have to recompile all the binaries by yourself. The estate is not signed. You can just tap into it, create your own bundles, and then use your own key, which is recognized by your own devices, to sign the updates. Yes? Well, signing is just a process where you generate a string starting from another set of strings. So, yes. The other question that I suspect you would be asking next is, can a device install a bundle from a different vendor? And the answer is, well, no, it shouldn't, because if I'm an ODM and I'm creating this line of devices, I want to have control over them, because there might be also some legal liability of what to do. So in that sense, and that's where I was initially saying that these devices, they operate in a much more sensitive field, because there might be legal liabilities. If I am an ODM, I have invested time, money, resources in doing additional testing. So at that point, I probably don't want to allow third party to tamper with that.
Businesses got, vendors got a business, and they leave their equipment out there for potentially somebody else to manage. Is that correct?
Well, what you do with your key, if you want to transfer it, that's your decision. What I'm saying is, as a vendor, you have control of who has the capability of generating software that can be installed on the device. Then it's up to you how you use this capability, but it is given.
Is it all or nothing, all bundles signed by the same key?
Currently, Ismo is the security guy. Currently, I think we are using one key only. Yes, we do not have 2 stages of authorization, but so far, well, also because so far the idea is that as a vendor, you sort of certificate that the various applications work nicely together. So in the end, if you are the one who's facing the end customer, you are the one who answers for malfunctions. So it's also, I guess, in your interest to ensure that only stuff that you have validated works well. But it's an interesting question. I don't think we have considered it yet. Any other question? Okay. Now I'm shifting a bit toward different concept, but we still tied into security. So currently we support only EFI devices for this topic that I'm going to discuss now. If you have any experience with generating images with the Yocto project, Yocto tools, you will see that this is a bit different from what you typically get. The stock image, if I remember correctly, is a MBR image which contains, it doesnnt even have a partition table. It is a MBR living inside the single and only partition, which is a FAT32, which contains a ext4 loopback file, which is mounted by the InitramFS. We wanted to add a little bit more of robustness to the implementation and also make it easier to create more complex scenarios. If you have played with more complex images in Yocto, you might have had the pleasure of dealing with weak. This implementation does away with weak, but it allows you to create a customized set of partitions. In particular, the idea of the Ostro layout is that there is, this is like the minimum configuration. You might have more partitions, but this is what is really needed to make it work. You have the GPT table, EFI partition. That's why I was talking about this being designed only for EFI. We have Ostro running also on BeagleBone and Edison, which are using U-boot, but they do not have this mechanism. So there's a secondary EFI partition, and then there's a rootfs, which is ext4. This one that I call the secondary EFI partition, in reality, it has a different partition ID. This is done because not all the BIOS implementations are fully compliant with the EFI specification. So it's better to not test how well your BIOS is compliant. The BIOS will recognize as bootable only the partition which has EF00 as a partition type. Now a quick description of how a normal EFI system boots. You have the EFI BIOS, which loads and validates. I'm assuming that these binaries are signed with a key which is known to the BIOS. So the EFI BIOS loads the EFI bootloader, GummyBoot, for example, or system dboot, how it's called nowadays. This one is in charge of loading kernel, InitramFS, command line, validate them, pass the command line to the kernel, and then the kernel is expected to enter the InitramFS, which will pivot root into the rootfs. As you can see, the chain of trust is composed by 1, 2, 3, 4 rings. And it means that one has to build into the bootloader and the InitramFS validation for the signing of the other components. But there is one alternative. This is nothing new, but it's not particularly used. The EFI specification allows for loading applications, but it doesn't say what an application really needs to be or how it needs to look like. The only part it cares about is that the beginning of the application needs to look in a certain way, and that is what the EFI stub is there for. The EFI stub is nothing else than the beginning of what is put inside the Gummy boot or systemd boot. And its sole purpose is to pass the kernel command line to the kernel. But what happens is that this is one single file which lives in the EFI partition. This one single file is loaded, validated, and executed directly by the EFI BIOS. So as you can see, there is only one single step of verification. And it's one which would have happened anyway, because we always start from the EFI BIOS. So we make it safer by completely removing these additional validation steps, which might bring bugs. If you wonder about this, I should have put a link. There's a nice description on James Bottomley's blog. He explains how to do all of this. What's the catch of this implementation? The catch is that since this is one single binary, and that's what I try to represent with this thick blue border, and it's signed, it's not easy to modify it. Or rather, if you are the signing entity, yes, you can. But if you are a developer who's, for example, trying to modify the kernel command line to enable or disable some feature, you can't unless you disable security in the BIOS, because the BIOS will refuse to load a binary which has a non-matching signature. So what can we do? The mechanism is the same that we can use for also update this EFI blob or application. The idea is we can treat the EFI partition as a special case, have a copy of that file and also others in the main rootfs. They are not active, meaning that the BIOS will not go and load them from here. They're just there as pure data until we do something with them. But this allows us to make them visible and manageable by the software update I described earlier. So this is the assumption is that what I'm running is always the EFI blob that was selected. So let's say that at some point software update delivers a new version of that binary, which might have a different command line for the kernel. In the EFI partition, I still have the old version of it. So after software update completes, it triggers a systemd service, which will, if needed, mount the alternate EFI partition, copy there the new binary, and then if you look at the partition type, you can see that from the earlier case where this was the active partition, which is characterized by EF00 type, now this one has become active. So it has almost atomically swapped active partition only after it has verified that the update was successful. The reason why I say almost atomic is that there's both a GPT and a backup GPT partition. So there are two places where this information is stored. So in reality, there are two places in the file, in the disk where the information needs to be updated, but it's executed with one single call to SGDisk. So it's pretty small window during which something can go wrong. The same mechanism can be used to handle, for example, multiple applications. Let's say that you have EFI application A, which you want to use for testing production setup and the EFI application B, which you want to use to test during development. For example, we have some security features like IMA, which can be enabled or disabled by modifying the kernel command line. So the ODM could provide to its developers these two EFI applications, and then the developer can decide which one to install based on the need. So one can easily switch between development mode for doing something and then production mode for verifying if the whatever was developed works correctly. Are there questions? This is just, I'm almost done. It's just a list of things that we need to do, which is basically try to upstream to Open Embedded and Clear Linux the modifications we have done. Plus, this is like my pet peeve, add the additional hardening. What would be nice is to put into the initramfs sufficient intelligence and tools so that it can detect if the rootfs was corrupted, damaged, tampered, and completely restore it. Because it's always preferable to at least attempt this sort of recovery than having some person who drives a few kilometers or miles to swap the box. Well, time-wise, there's a bit more than 20 minutes. If you have any questions or if you, yes.
I'm not clear on the relationship between validating the bundle and validating the equipment. Are you using the same keys to validate the?
You could. There are several keys involved because there's the key which is used by the BIOS to validate the EFI blob. Then, here I don't know if I should hand over the answer to Ismo, but once this preliminary validation has completed, then we are running in initramfs. At that point, if you have IMA and SMAC disabled, these are sort of expected to guarantee that once you switch to executing files from the rootfs, those have not been tampered with. I haven't put it in the slides because we haven't implemented it yet, but the idea would be to have rootfs, which is read-only. So nobody is supposed to modify it, and the signature are supposed to match the content. And then there should be separate areas where, for example, either with bundles or we are considering also containers, one might install additional applications. Bundles maybe are more effective for deploying native content. So you might want to have some interpreter, for example, Python, Java, something like that. And you might prefer to have your custom application in a container. But there's a high level of variability in this sense of how you like to tailor your system, what is your legacy. So that part we really don't want to enforce. It's more about enabling what our potential customers might request. Does this answer your question?
Yeah, sort of. Typically, when you load something from a file into memory, there are some changes that are made to the file. So a signature over what's in the file is going to differ from a signature that's in memory. You need different hash values and variants and things validation. And so that implies that there's some process for obtaining those hash values and ensuring that they're legitimate. I didn't see any of that described.
Yes, well, the thing is, me and Ismo have been presenting both, so I didn't want to overlap too much his presentation, but the bundle deployment process is supposed to include also extended attributes, which are used by IMA and SMAC. So the idea is once you deploy a file with a bundle, the extended attribute is part of the calculation of the generation of the hash. So once you have the hash, it means that date, content, attributes of the file must match. And that's what the software update client uses. The overall security is done so that you have each manifest containing reference to files and hashes. And then there is a second level manifest, which is called manifest of manifests, which contains hashes of each individual manifest. And that one is assigned so that you can confirm that if that one has not been tampered, then it cascades down to the rest, that also those have not been tampered. I hope this is a better explanation. Okay, Ismo, do you want to add anything? If there are no other questions, thank you for listening.